Welcome to KEX, Construction Engineering. Stop reinforcing your cantilevers like they're just standard floor beams. It is the most common reason for structural cracks and catastrophic failures in buildings. Today, we are showing you how to master cantilever beam rebar details and fix them correctly on site with zero errors. To translate this cantilever beam detail from the blueprint to site reality, we first need to set out our grid lines and establish our primary supports accordingly, so pay attention as we proceed. The length of this cantilever beam is 1.5 meters, A to B. Fixing of beam bottom formwork. Fixing of 25 millimeters beam cover. Without wasting another minute, let's start reading and executing the cantilever beam rebar details. To make this easier and faster, let's read and form the top and bottom reinforcement first. 3 numbers of 16 millimeters diameter bars are required as bottom bars B1. This is how to fix it on site. For top reinforcement, T1 to numbers of 16 millimeters diameter bars are required. This is how to fix it on site. Now, let's take note of the varying stirrup or link spacing at the mid-spans, supports, and the cantilever section. To simplify this, the drawing specifies links at 225 millimeters spacing at mid-span and 150 millimeters center to center at both the supports and the cantilever section. We space the links closer at the supports and cantilever because that's where the beam faces the maximum shear force. Using closer links balances these forces and ensures the beam is structurally sound. Now, let's read and fix the extra bottom bars. To Y16, extra bottom bars are provided at mid-span to ensure the beam meets its design capacity for positive bending moments. Let's read and fix extra top bars. Ensure you verify their length using the L/for rule. Additional or extra top reinforcement are provided to handle negative bending moment or the intense tension forces concentrated at the supports. Now, let's move to installing the cantilever beam reinforcement. Crucial note, before you execute any cantilever detail, ensure the design has been certified by a licensed structural engineer. Cantilevers are high-risk elements, never guess the design. Always follow the approved structural plans to prevent failure. Please remember, this drawing is for educational purposes only. In a cantilever beam, the top bars serve as the primary reinforcement, unlike standard floor beams where the bottom bars carry the primary tension. Therefore, ensure the top reinforcement is fixed exactly according to the structural design. Deviation from these specifications is a critical error that can lead to structural failure. In this drawing, we have 4 top bars for our primary reinforcement. But keep in mind, for longer cantilevers or higher loads, the design may call for a second layer of top bars. Always check your project's structural schedule, as the total amount of steel required depends entirely on the specific span and loading conditions of your beam. With the cantilever reinforcement successfully installed, let's move forward to complete the rest of the structure. This will allow us to see how these intricate reinforcement details translate into a robust, finished concrete cantilever on site. Construction of slab formwork. Placing of 25 mm concrete cover. Installation of simply supported beams. Fixing of slab bottom bars. Y12 at 200 mm center-to-center spacing. Fixing of slab top bars. General inspection of reinforcement work. Fixing of external formwork. Pouring of concrete slab and beams. Ensure proper vibration to remove air bubbles and avoid honeycomb. Formwork removal. Remember, curing is vital. This is the stage where the concrete gains its final design strength. Without it, even a perfectly reinforced concrete structure will fail to perform. Now let's see the completed cantilever beams. Good. This is the end of this work. I upload construction videos here every week. Yes, there are many construction videos on this channel. Go ahead and ask whatever you don't understand. I always reply, thanks.